Friends, let us continue with the discussion on the 16th lecture in module 1, where we are going to solve another example problem in planar non-orthogonal frame, but we will solve this problem directly using the computer code. Okay? We will not solve this by hand, directly we will simulate the labels and the program lines in the code, use the solution directly from the code and interpret the results. Okay? The example problem is like this. Before looking at the problem, let us quickly revise. We have to identify the j and k n of each member, locate the local axis, compute transformation matrix coefficients and then the matrix, get the transpose, identify unrestrained and restrained set of degrees of freedom labels, get local stiffness matrix, then global stiffness matrix, get k bar global total matrix and k bar UU for the structure. Since axial deformation is added in the analysis, k of every matrix local will be of size 6 by 6. Estimate the k matrix, find the k bar, assemble and get k UU bar. Find the fixed end moments from the member loading, find FEM bar using this relationship, then estimate the joint load bar in reference axis degrees of freedom, plug out only the unrestrained values, find the displacement in unrestrained degrees and find the end moments and shear force in each member in global degrees of freedom. That is the steps involved. Let us take an example which I am marking here. I am taking a similar example which creates some similarity with the existing code. So, it is easy for you to follow. Okay? Let us say the I value of this member is 2.28 10 power 9 mm4 and cross section area is 1.35 into 10 power 5 mm square. The I value for this member is 3.125 10 power 9 mm4 and cross section area is 1.5 10 power 5 meter square, and moment of inertia for this member is same as the vertical column, which is exactly the value which I am writing on the board now. Let us write down the dimensions of this system. This is 6 meters, okay. This is 2 meter and the height of the structure is 4 meters. Okay. E is constant, same material, maybe steel, maybe concrete, does not matter. Let us try to find the value theta. So, theta will be exactly equal to tan inverse of 4 by 2, which is 63.435 degrees, which will be as same as this value, is it not? Okay. Now, let us mark the degrees of freedom for this problem. I will do it separately. Let us say the global reference axis is marked here and the degrees of freedom label are with reference to that. So, this is going to be unrestrained degrees theta bar 1 theta bar 2, delta bar 3, delta bar 4, 5, 6, 7, 8, 9, 10, 11, and let us now mark the local axis for each member. So, let us say this is my xm and ym for member 1, this is my xm and ym for member 2, and this is my xm and ym for member 3. Okay, now, I would like to know what is the angle of inclination of each member with reference to my global axis x and y. So, for this member this value is 90 degrees, for this member this is 0 degrees, is it not? For this it is going to be this is my reference axis x. So, one can see here this is rotated clockwise, okay, by a value 63.435 degrees, which is negative because clockwise. Okay. Let us see what are the labels for member AB. For member AB, what are the labels? The global labels are, so the labels are 7, 1, 9, 4, 8, 3. Similarly, for the member BC, the labels are 1, 2, 4, 6 and 3, 5. For the member CD, the labels are 2, 10, 6, 12 and 5, 11, correct. So, rotations along y along x, rotations along y along x, rotations along y along x, rotations along y along x. So, one can identify the labels. After doing this, let us make a table. Let us say the member, the joint which is my j and k n, and then the length of the member, then c x, c y after knowing theta. So, I think you will be able to compute this for the member 1, that is AB, for the member BC, for the member CD. These are A and B. Let us say this is A, this is B, C and D. Okay. AB, BC and CD. Li, this member is going to be 4 meters, this member is going to be 6 meters, this member is going to be square root of sum of squares, which is going to be 4.472 meters. So, the angle is 90, okay. So, cos 90 and sin 90, this angle is 0, cos 0, sin 0, and this is going to be 0.447. Cos of minus theta is simply cos theta, sin of minus theta is minus sin theta. Okay, we got the values. Once I have this, I can now find the transformation matrix. Let us go to the program directly.